Hi guys, Dr. Diaz here again. Last video, promise. So let's try to solve this problem, the hyperbolic problem. It's a hyperbola. It's actually a kind of difficult one because it's the one that the expression is all expanded. And I would suggest you guys look at the book section, the exercise in section 6.3, and try to solve like 18, 19, 20. I will say from 17 to 20. This actually is 19. I already solved 19. So let's work on this one. The first thing I did is I wrote this equation back here, and as you remember, what we're going to do is regroup x with x and y with y. So it's going to be 4x squared minus 8x, and the y's, which is going to be minus y squared plus 6y, is equal to 4. And then we send 4 to the other side of the expression. Then here we're going to take as a common factor 4. We will have 4, and we have what? X squared minus 2x. And then here we're going to take as a common factor, actually negative 1, minus y squared minus 6y is equal to 4. Right? If we multiply back negative 1, well, negative times y is going to be negative y squared, and negative times negative is going to be positive 6y. And the next thing you remember, the same procedure as doing completing the square. We take negative 2, we divide it by 2, and we square it. So it's going to be negative 1 squared is equal to 1. And here we're going to take negative 6. Negative 6, we divide it by 2, and we square it. So it's going to be negative 3 squared is going to be positive 9. Now what we're going to do is we're going to add here 1, we're going to add here 9, but we had to add those things here, but not exactly those numbers because there's a 4 here. So it's going to look like this: 4x squared, minus 2x plus 1 minus y squared minus 6y plus 9 is going to be equal to 4. And how much are we going to add here? Well, it's going to be 1 times 4, so plus 4. And what about this one? Well, this one is going to be what? Negative 9 minus 9. Because instead of subtracting, I mean, we're adding here 9, but there's a minus sign, so it's going to be negative 9. And this thing is going to look like, let me show you here, it's going to be now negative 1. So we will have something like this: 4x squared minus 2x plus 1 minus y squared minus 6y plus 9 is equal to negative 1. And this thing, we're going to do something with the negative sign in a second. This thing here, if we do, the reason why we did complete the squares because we turn this into a perfect square trinomial, the same thing as this one, and we can write this in a factor form, which I'm going to scroll here a little bit down. And in writing this as a perfect square trinomial, we have x something squared minus y something square, for the square here, and who is the something goes here? Is this number here, negative 1. So let's put it here. And who goes here is this one, negative 3. So there we got it, negative 1, negative 3. And well, remember that the equation, the hyperbola, should look like this. Let's put here 2 equations. One, it could be x squared divided by a squared minus y squared divided by b squared equal to 1, positive 1. And the other one could be y squared divided by a squared minus s squared divided by b squared equal to 1. So it has to be positive 1. We have negative 1 here. So what we do, we divide it by negative 1. Actually, we should divide first, yeah, we should divide by negative 1. And this 4 here, we're going to change this 4 in a little bit. So first, divide everybody by negative 1. You will have then, this one is going to turn positive, this one is going to be negative, so it's going to be then y minus 3 squared, because divided by negative 1 is turned positive, plus 4x minus 1 squared is equal to positive 1. Now this one here is like having a 1. This one here, how are we going to find this one? This is the same as 1 over 1/4. So let's rewrite this equation again. We have y minus 3 squared divided by 1, which it would be a squared. Okay, I don't know why I put plus. It has to be minus, because if I divide by minus 1, this one's going to be negative. Minus, and here we have x minus 1 squared divided by 1/4. This is equal to 1. Now this one looks at the equation with parabola. It's a kind of strange equation with parabola, and actually I probably took one of the difficult problems, but it's other than want to do 18 or 17 because it's easy for you guys. You can practice that one, and then you do 20, which is a little bit tough, but I want to show you this one so you guys don't feel a little bit lost when you do this one. Yeah, I try to help you a little bit, so pay attention. Okay, so stop this one in a second. I'm gonna wait, I forget to say it. The center, where's the center? So we can see that the center here, center is h and k, which in this case is gonna be 3 and 1. Actually, it's 1 and 3. X is 1 because here this is h. Center is always h and k. So the h is 1, so it's going to be 1, and here 3. All right. We know this parabola now is aligned along the y-axis. Yeah, because we divide by -1, everybody changed their sign, and now the y is positive, regardless of what is this number. So we have the center, 1 and 3. Let's look at a squared. A squared is equal to 1, so a is equal to plus or minus 1. That's perfect. Good. B squared is equal to 1/4, so b is equal to plus or minus 1/2 because it's the square root of 1/4 is 1/2. Yeah, check it, guys. Square root of 1/4 is equal to 1/2, just in case. Okay, so now we have a, we have b. That means we can calculate c because c squared is equal to a squared for plus b squared in the case of hyperbola, which solving for c, we will get c is equal to the square root of a squared plus b squared. It's going to be the square root of, we have here 1 plus 1/4, which is going to be the square root of 5/4, which if you take the square root of this thing, is going to be square root of 5 divided by 2. That is c. So we got c. And then if we're going to find the focus, because we have 2, we have 1 that's going to be 1 stays the same, and then we will have 3 minus square root of 5 divided by 2, and the other one is going to be 1 stays the same again, and this one is going to be 3 plus square root of 5 divided by 2. Check the formula sheet that I gave you. It's giving you more or less the formula. Okay, so we have focus. We have C. Oh, let's calculate the eccentricity. Look at that one. And it's going to be E is equal to C divided by A, which is going to be C is the square root of 5 divided by 2 divided by A, which is actually 1. Oh, look at that. It's 5 divided by 2. Square root of 5 divided by 2. Okay. It's kind of weird, but what it is. Let me scroll this one up a little bit, because now we're going to find the asymptotes. Okay, finding the asymptote. Okay, asymptotes, we have here y for the equation where it's a line along the y-axis is equal to b divided by a, x minus h, and k plus k. And then the other one, I'm going to write here in a second, and y is equal to minus b divided by a, x minus h plus k. So this one is going to be, you remember, b is equal to, actually, b is equal to 2. You see? Sorry guys, I made a mistake. I just changed it immediately. It was a divided by b, x minus h plus k, and minus a divided by b, x minus h plus k. So in our case, a is equal to 1 divided by 1/2. And then we have x minus, let's put here the other equation, minus 1 plus 3, which end up being 2, x minus 1 plus 3, and if you, well, distribute here, this is going to give you 2x minus 2 plus 3 is going to end up being 2x minus 1. This is the first line asymptote. For this one, it's going to be, now I'm going to write here in a second because I don't have much time, and we end up with y is equal to negative 2x plus 5. Here's one of the slant asymptote, here's the other slant asymptote. They both have the same slope. So what we're going to do now is we're going to graph it. Let me go here, scroll this a little. And guys, I forgot to put the vertices. I forgot to find the vertices. So the equation for the vertices for hyperbola line along the y-axis is hk minus a, which we got it here. I had to look at the center again, and I had to look for a and b, which is all the way up there. So it's going to be 1, and 3 minus 1 is 1 and 2. So we have it here. And x is 1, y is 2, and the other one, h is k plus a. A is plus or minus 1, is plus 1, and it's going to be 1 plus 1, and 3 plus 1 is going to be 4. Here is the two vertices. Now we know we can do the square thing, because remember I told you we have a, which is going to be 1. It goes from 1 to 1 and minus 1, and then b goes to 1/2 and 1/2. So let's go look at this one, the graph. Yes, but I don't think that will work here, because this one is not centered on the origin. So in this one, you necessarily need to use these two equations that we have here, the asymptote equation, because when it's centered on the origin, it's easy to know that it goes from a minus a, b minus b, do the square thing, the rectangle, and throw the lines. That's when it's centered on the origin. When it's not, then it's better use the equation. And if you use the equation, we're going to draw the lines using the equation. I tried to put the points here because I know it's going to be around here. We can do the square here, and I'm going to do the square in a second. Let me show you this in a second. And now, guys, now throwing those vertical asymptotes, I noticed that I made a mistake here, because minus 2 plus 3 is actually not negative 1, but positive 1 is plus 1. And when I was doing the graph, I noticed it's going to intercept by 1. So, oh, yeah, I made a mistake out in here. So, yes, it's y is equal to 2x plus 1. Y is equal to negative 2x plus 5. And here is, in the asymptote, I mean, the hyperbola goes something like this, something like this, something like this, and something like this. So check here, I made a mistake here with the sign. Minus 2 plus 3 is actually plus 1. And here's your hyperbola. Guys, I hope this helped a little bit. So hope to see you in class Monday. Take care, guys. Study.